Hey everyone, my name is Nate Aerosmith. I'm in EP20 and I'm currently taking Accounting 555. A number of people in my class have been complaining about the difficulty of some of the quizzes and not feeling like they have enough time to solve all of the math problems that they're presented with in the course. I certainly have a bit of experience solving math problems like this as an industrial engineer. But prior to engineering school, I actually worked in politics. So when I first went back to school, I was in for somewhat of a rude awakening when I first started to have to solve, kind of sophisticated word problems like the problems we've seen in class so far. So over the course of learning how to solve problems like that in engineering school, I developed a few tricks and methods that I continue to use today. And I decided to put this together to help some of you along in your learning process, and then also to help you get through quizzes and tests a little bit quicker. All right, so the key idea to effectively solving math problems, any sort of word problem, is the ability to focus. And when I say focus, I don't mean concentrate in the strictest sense. It's really not about concentration. Focusing is more about organizing the information you're presented with in a logical and efficient way, and getting rid of extraneous information that isn't going to help you get through the problem. Additionally, it's about having a framework for how to solve the problem. Sometimes these might be called algorithms. Don't worry too much about the word. Algorithms really just means steps or process. But so to summarize, the core concepts here, if I had to break it down really simply, it's about getting rid of extraneous information, focusing only on the things that matter, and committing yourself to a course of action, a rigorous set of steps that you're going to follow to get through the problem as quickly and efficiently as possible. So what do I mean when I say eliminate everything that is unnecessary? So most of the information in a standard word problem is unnecessary. All you're really looking for here is to identify the variables and what the real ask in the question is. I think you'll see in an example I have coming up here that's actually ends up being a lot of words in some cases. If you took some of the recent quizzes in 555, you'll note that there were even numerical information in the problems that you didn't need to solve them. So the key is identifying what's important and what's not. And part of the way that we can do this effectively is we rewrite every problem. So you'll go through and you'll highlight the variables and other aspects of the problem that are important, maybe underline them, and then transfer those to a separate piece of paper or somewhere on your answer sheet in an organized fashion, so you can just really get rid of all the extra extraneous stuff that you don't need. And in that case, to really make this effective, you should get in the habit of doing it for every single problem. So what's that look like? All right, so here's a problem from a couple of quizzes ago. The example question is, a company currently breaks even at 1,000 units. Its fixed costs are $40,000 and its variable costs are $10 per unit. What is the product's selling price per unit? So you can see here in the top part, I underlined the key sections of this problem. Breaks even at 1,000 units, fixed costs are $40,000, variable costs are $10 per unit, and selling price per unit with a question mark on the end. I rewrote those down below it. Taking that one step further, though, we can really kind of boil this down into variables. In this case, we have BV representing the break-even volume, FC representing the fixed cost, VC representing the variable cost, and SP representing the selling price per unit. So, you could even throw a question mark on the end of SP if you wanted to remind yourself that that's the variable you want to solve for down the road. So already we've simplified this question pretty considerably. All right. So math problems, a lot of people tend to think of them as really being all about numbers, but math is actually about relationships. Arithmetic, i.e. adding, subtracting, multiplying, dividing, is a really small component of mathematics. And I think a lot of people get tripped up with arithmetic. But in truth, you can do most math without numbers the majority of the time. It's only really at the beginning or an end of a problem that we concern ourselves with numbers themselves. For the most part, we're going to be focused on just the relationships that exist and rearranging those to try and find a formulaic way to get to the answer. But no numbers, how? So being an efficient problem solver really does come down to eliminating all unnecessary information, and numbers are kind of, in a way, the ultimate in unnecessary information as you go through and try and solve a math problem. This might be counterintuitive, but in a world of formulas with multiple variables and things like that, the truth is you don't really need numbers until the very end. You kind of plug them in when you need them at the last step. And this gives us a lot of advantages. For starters, you don't have to keep track of, random numbers or decimal places as you're going through a problem, trying to do mental math that might jumble up your thinking. It's really something that calculators are great for. And if in simpler problems, you can do it on pen and paper at the end. But it's something to really keep in mind that numbers are oftentimes the enemy of efficiently solving a problem. So what does that look like in practice? All right, so you'll remember our example from before. We had the break-even value was 1,000 units. The fixed cost was $40,000. The variable cost was $10 per unit, and the sales, or what was that? That's the sales price was unknown at, we'll call it X dollars per unit. We can get rid of all the numbers here, so let's just rewrite that. As you can see there is BEV, FC, VC, and SP, and you could even write, again, you could add a question mark at the end of SP so that that's the one you're trying to solve for. Now what we have to do is we have to figure out how we're going to manipulate these variables to get the answer that we want. In this case, we'll use an algorithm. Algorithms, I mentioned this earlier, and I think I went over a little bit about this on an earlier slide, but algorithm really just means steps or process. An algorithm starts with inputs. You perform a series of operations on them. There's a specific order typically to how you perform those steps, and then you get an output at the end. Different algorithms can accomplish different things. Some are more and some are less efficient. Some algorithms will get you the answers and others won't get you the answer you want at all. The example I would like to give for how to understand algorithms, it's kind of like putting on your pants. So most people put their pants on one leg at a time. That seems to be the quickest way to do it. Some people start with the right leg, some people start with the left. Those are different algorithms. But at the end of the day, they take about the same amount of time. But if you were to kind of jump on your bed and pull your pants on both feet at the same time, that might be a little bit slower in reality, but it gets you to the same result. So we can see that there's kind of an example of different algorithms for putting your pants on. And solving math problems is kind of similar. There's more than one way to skin a cat, so to say. But choosing the right algorithm can get you to the answer quicker, which I know for a lot of people kind of struggling through some of these math problems, that's something you want to consider is, am I making the right decisions in terms of how I get through these problems? Okay, so choosing the right algorithm approach is really important. It's one of the most important things to efficiently get through problems. Kind of having a sense for what sort of mathematical operations you need to be doing. But you don't necessarily need to know every single step of the algorithm you want to use while you're doing it. In truth, you can really focus, if you have a good idea of what sort of algorithm you're supposed to be using, you can really focus on what your next step should be. This is an important thing to remind yourself of. You don't have to try and figure everything out all at once as you're working through a math problem. You just need to choose the right next step. And I think as you gain practice with sorts of problems like this, that'll begin to make a lot of sense. It might not make a lot of sense right now, but just focusing on understanding the next thing you need to do in order to solve the problem will really garner a lot more success for some of you. So we can build our algorithm incrementally is the real takeaway from this slide. So the business school algorithm is something, a term I've coined. I'm sure it's probably been coined elsewhere before, but let me just read through this. That'll probably help everybody out for simplicity's sake. But business school problems frequently follow a general framework. You will be provided with a number of variables. You will need to solve for one of those variables and be provided with values for the others. Okay, so this is kind of like the problem we've been working through, which you'll again see in a minute here. But some important caveats to this. You'll often have a formula sheet, or you will be expected to know the formulas you need ahead of time. It's pretty rare that you'll be expected, at least in business school, to derive some sort of complex formula. If you think about any of the classes you've taken so far, you've been presented with a lot of ideas and relationships between numbers. If it's the quantity times the selling price, equals revenue, right? So you'll have that up front. Next thing you'll need to do is you will have to search through all the formulas you have for the one that contains all or a subset of the variables you have, including the unsolved one. That's important. So when you find that kind of that set of formulas that contain those variables, once you've identified that, you'll want to choose one of those formulas, ideally the one with the fewest variables that you all have, and you'll rearrange it using algebra until you've isolated the unsolved one. This is probably, if I had to guess, of course I'm a first year MBA student, but if I had to guess, this is probably 90 to 95% of all business school math problems based on what I understand. So once you've done that process, the resulting formula you have can be used to generate your solution by plugging those numbers back in. All right, so let's look at an example of this a step further here. So previously we identified our variables as break-even value, BEV, fixed cost, FC, variable cost, VC, and selling price, SP. We've been asked to solve for SP, and we already know the other variables. So let's say we go to our formula sheet and we find a formula here. This one is break-even value times the selling price minus the variable cost equals fixed cost. Okay, that's a pretty reasonable formula. Basically what it's saying is, you know, my margin times the break-even value or break-even volume, excuse me, equals the fixed cost. And that makes sense if you're familiar with the concepts underlying these different terms that I'm using. If you don't understand those, you probably might want to go back to your book and understand what those terms mean. But again, this is just kind of a fundamental relationship. We haven't said anything about numbers specifically here, and just looking at this formula, these are just the underlying relationships that exist between these values. All right, so taking this a step further here, how would we isolate the sales price or selling price? Well, we need to isolate the selling price, as I said. So, you know, as you can see here, this is some pretty basic algebra here. In this case, we're just going to divide both sides by the break-even value. That'll leave us with the selling price minus the variable cost is leaving equal to the fixed cost divided by the break-even value. Similarly, then, we want to get the variable cost away from the selling price, in which case we add it to both sides. And that leaves the sales price equal to the fixed cost over break-even value plus the variable cost, right? So you might be thinking, okay, we're done now. We've got, you know, this formula here. We have sales price isolated, and all we have to do is plug in numbers. This would be a rookie mistake, in my experience. You know, it's really important that we check this formula out before we use it. Otherwise, we're liable, you know, especially if we're stressed and under a time crunch, to just kind of plug the numbers in and go for it. So how do we check this? Unit checking is probably one of the single best ways to check that we haven't made any mistakes if you're working with formulas with kind of mixed values. If you're not familiar with unit checking, I'm going to explain it in a second. It can come off as a little complicated at first, but ultimately it's a really, really useful tool to make sure that your units match. And that is a loose validation that the mathematical operations you've performed were consistent with what you want to get out of the process. All right, so what does that look like? So recall really quick that break-even value was 1,000 units. Its unit of measure is units. Fixed cost was $40,000. Its unit of measure was dollars. Variable cost was dollars per unit, so it was $10 per unit. So its unit of measure is dollars per unit. Selling price was dollars per unit as well. So as we can see, if we look at this, our formula again, SP equals FC divided by BEV plus VC, and we just substitute in our units of measure into the formula. We get on the left there is dollars per unit equals dollars over unit, i.e. dollars per unit, plus dollars per unit. And because the units on both sides of this equation match, everything is in the same form, we can be pretty confident that we've transformed this equation properly. We haven't made any mistakes in our math. So this is a really reliable thing to use to check it. Actually, as I was going through and putting this slide deck together a week or two ago, to tutor a couple of people. I made a relatively minor math mistake and didn't catch it until I got to this slide. So, even the best of us, if I can be so inclined to call myself the best, make mistakes, and it's through checking our work that we avoid passing those mistakes on to others or letting them affect our GPA. So at this point, we're ready to solve. So we know that SP equals FC divided by BEV plus VC, and we know what our variables, our known variables anyway, are equal to. So if we just plug those variables in at this stage, we get an answer out. And in this case, it was $50 per unit. So the first thing we want to do after we've gotten an answer, this is an important thing, is to ask ourselves if the solution makes sense. So if we had gotten an answer that was, I don't know, $5 million per unit, that wouldn't have made a lot of sense given the other numbers that were at stake there. Wouldn't have passed what we might call the sniff test. The other thing we want to look at is we want to reread the original problem statement. We have an answer now. Is our answer we have making sense relative to all the information, maybe the information that we left out? Did we maybe miss an important caveat? Hopefully we would have caught that to begin with, but just to be absolutely sure, now that we've put on all this work, that it wasn't completely wasted, we check that. Additionally, we should check the operations we performed. While we might have done a good job with our unit checking, it doesn't mean that we didn't make a small mistake somewhere along the line and it just kind of came out in the wash and worked itself out. So always be sure to check that. And really is an important caveat to add too, is that you should record every single step that you've made up to this point. Whenever you perform a mathematical operation, you want to write that down separately so that you're always working kind of fresh. And then, of course, after checking your answer, you want to write the answer down in the box. Gosh, I probably, several times in my life, I've diligently worked my way through a math problem, maybe 2 or 3 times because I couldn't quite get it at first. And then I forgot to circle the final answer and got dinged for a point or two because I didn't do that. So just make sure you conform to the expectation. I know under a high pressure situation that isn't always possible, but it's always worth a shot. All right, so to reiterate the whole thing, to bring it back, one of the keys here, one of the key things that you want to always be doing is focusing on, is to focus itself. And by focus, again, we mean that this only means to kind of remove extraneous information from what you're considering. It doesn't mean concentrate really, really hard and give yourself a mild heart attack or whatever. It just means to just take the information you need at each given step and concentrate on that. Again, we want to rewrite the problem. This is really important because we want to put it into terms that we can understand. And again, this kind of reinforces the idea of focus that we need to incorporate into how we approach solving these problems. Additionally, we want to ignore formulas you don't have variables for. In tutoring some folks, I've seen them really run wild with formulas that they didn't have values for variables that were included in that formula, and they just kind of went off into the wilderness on it and really struggled to figure out why it wasn't working for them. Additionally, you want to record every step that you take. Every time you perform a mathematical operation, you want to write that down. Frequently, it's useful to rewrite the problem as a new line. I know it feels like a long time, but in truth, it only takes a second or two, and it saves you a lot of hassle later on if you realize that you've made a mistake and want to go back and kind of restart from where you left off or from where you had done things correctly. And then, of course, check your work. That's probably one of the biggest things that you can do to help improve your performance. And if you're working diligently and efficiently, you'll have plenty of time to do it. Emphasis on efficiently, but that'll make a big improvement for your overall outcome if you just make sure at the last step that the numbers you're generating are making sense across the board. And last but not least, be sure to breathe. The only thing you really do have to worry about is your next step in math. And so as long as you focus on the task at hand, which is the work you're currently doing, and then once you've resolved that, moving on to the next part of the problem, you'll be able to get through it in an efficient way. So if you have any questions, feel free to email me. I can be reached at nea20@georgetown.edu. This is Nate Aerosmith again. Thanks for listening. I hope you found this helpful, and let me know if I can be of any help.